Alright, welcome back. This is going to be question number 13. I decided to make videos for each one just because for me to manipulate the screen and everything, it's a little tricky. So I think this will work better. Alright, so we have three people. Connor, Tiana, and Gage are driving to choir practice in their Honda Civic at 20 meters per second when they see ice cream cone in the middle of the road. Connor, the driver, takes 0.8 seconds to react, then steps on the brake and slows at 7 meters per second squared. And to be sure, because you're slowing down, it's a negative acceleration. It's not like he applied the brake and then he sped up. He slowed down. So how far does the Civic travel before it stops? So let's go through this here together. This is actually a two-parter. So let's talk about part one. Part one is when Connor takes 0.8 seconds to react. During that 0.8 seconds, the car is moving at this speed, and so we can find out how far it had moved. And then the second part is the slowing down part. So we'll figure out both those. Part one is actually quite easy. So let's just see what we can do here. So I'm going to call this one part one. A nice little box that doesn't quite fit. It's going to kill some people, so I'm going to make it. Oh my goodness. Here we go. Look at that. Oh, yes. Okay, part one. So, what kind of information is given for part one? Part one is this car is speeding at 20 meters per second. So that's actually the average speed. It's at 20.0 meters per second. Okay, and the change in time, delta t, is 0.80 seconds. And what are we trying to find? How far does the Civic travel before it stops? So we're going to find out how far it travels. I'm going to call this delta d1 because we're going to find out how far it travels in the second section as well. So let's do this one first, and then we'll do part two after this. So what equation we're going to use? We have v bar, delta t, and delta d, and we're trying to find delta d. Well, there's only one equation that has delta d in it, so we're going to be using that equation. I guarantee it. And the nice thing is you have all the things that you need. You just need to rearrange the equation. So I'm going to do that. We want to get delta d by itself, so I'm going to multiply both sides by delta t. So you're going to have delta t v bar on this side and delta d on this side. Okay, and so we can simply just go delta d is equal to delta t v bar, which is equal to 0.80 seconds times 20.0 meters per second. And you'll find that that equals 16. Now, we can only have two decimal places because we only have two here. This one's not a significant digit, so we can actually only have two in our answer. So it's just 16, not 16.0. Okay, so while Connor's reacting to this incident, 0.8 seconds, the car traveled 16 meters. So, second part. How far does the car go when the brake is applied? So this is going to be called part two. Okay, now I'm just regretting not using another color. Boom. Let's do another color here. Try this. Hopefully you can see the screen. Part two. There we go. Alright, so now part two, we need to figure out what's going on. Well, now we know that the car was going 20 meters per second, like in part one, but now the brake is being applied. So actually, this is not the average speed anymore. This is actually just the initial speed. So we can go VI is equal to, VI is equal to 20.0 meters per second, and we can do the acceleration is actually a slower acceleration. Just before we do that though, this is not said, but the final speed is going to be 0 meters per second. That's what a stop means. You're not going anywhere. And the other thing that's said here is the acceleration, and we're braking it at constant acceleration, or an average acceleration of 7. So we're going to go minus 7.00 meters per second squared. And that just means the acceleration is going in the opposite direction of the car movement, or of the speed. So we need a minus sign there. And the last thing is we're actually trying to find is delta d square, delta d, and I'm going to put a 2 there because it's the second part, and we're trying to find that. Again, we start off with the same equation because there's only one equation that's delta d, but everything else is just a little more complicated. So v bar is equal to delta d over delta t. Well, we know from doing all this that we can say that delta d is equal to delta t v bar. Okay. Now the question is, do we have anything? Well, we don't have delta t. We don't have v bar. So we're actually going to have to figure out both items here. And so what I'm going to suggest is we do one at a time. So let's first do delta t. Now we've already used this equation, so we can use this equation here. And so that's what we're going to do. A bar is equal to delta v over delta t. Now we rearrange the equation. We'll multiply both sides by delta t. So delta t a bar equals delta v, and then we'll divide both sides by a bar. So delta t is equal to delta v over a bar. Okay, we'll substitute that in for the delta t, and so we'll have delta t is equal to delta v over a bar, and actually times v bar, but I'll just put the v bar up here like that. Okay, and now we got to find an equation for v bar. So we've used those two equations. Well, v bar actually only exists in this one now, so v bar is equal to vf plus vi divided by 2. We'll throw that in there. The only thing is vf is 0, so we can put just a vi divided by 2 there. You know what, I kind of regret having this. I'm going to erase this. I'm going to put this as a separate thing because I think you're going to find that v bar like that this is going to look nicer. Hopefully you'll like it. Okay, delta d is equal to delta v a bar times vi divided by 2. So these two fractions multiplying by each other. Now we're trying to solve for delta d, and so we actually have everything we need there. I can combine it into, well actually sorry, I guess we don't. We have delta v here. That's a problem. So we've used these equations here. Delta v, I didn't realize or recognize that we don't have that one. So we actually need an equation for delta v. Nice, there's one right there. Delta v is equal to vf minus vi. We already know that vf is 0. Be careful here, that minus sign needs to stay there. So this minus vi gets put in for here. So we have delta d is equal to negative vi times vi essentially. I'll put them in separate fractions for now just so you can see what I've done. But now we'll multiply it all out. So I'm going to go up here. Delta d is equal to negative, what's negative vi times vi? It's negative vi squared. And the squared is over the vi and not the negative. Negative is separate. Okay. Divided by 2 a bar. Now you just put the number in front because it's just a nicer convention, I guess. What I'm used to. Okay, we are solving for delta d, so now we can simply put in the values. So hopefully that's not too complicated. Let's throw that value in there. Delta d is equal to negative 20.0 meters per second squared divided by 2 times negative 7.00 meters per second squared. Like that. Okay. So you can see there's going to be two negatives. They're going to cancel out. If you do the calculations for all this, you should get 28.571 meters. How many decimal places can we have in this one? Well, on this one, actually, we have 3 decimal points, so we can go delta D is equal to 28.6 meters. All right. Now, are we done? We found out the distance for part 1 and for part 2. Yeah, we're kind of done, except for how far does the Civic travel before it stops. You need to add the two distances together. I'm going to use a nice purple color. So we're going to say delta D, and I'm going to say T for total is equal to delta D 1 plus delta D 2. So that's going to be equal to 16 meters plus 28.6 meters. And really, in order to not have any round off errors, you should use this this version of the delta D. So 28.571 when you add it together. In this case, it won't make a difference, but in other cases, it might. You might, because this is a rounded off version. In this part of the question, that rounding error or rounding can kind of add on to one another. Like if this was 28.47, it would round up to 28.5, and then when you add it here, it'd round the next one up. So we don't want to do that, but in this case, it won't make a difference. So let's continue. So this is simply going to be 44.6 meters. You can only have, for addition, it cuts it off at the ones place, so this is going to make the 4 round up to 45 meters. That's it. That's your answer. So Connor and the gang here would, on their way to choir, they would have, their Honda Civic would travel 45 meters. 45 meters before coming to a stop. So, and since they're going 20 meters per second, 45 meters is not that far at all. So I don't know if they got the ice cream or not, but that is how you answer that question. I'll do the last question in the next video.